Hello, everyone, and thank you for joining us. I'm Cassidy Phillips, VP of Networking Solutions Architecture, and most of my background has actually been in operations in my career, so I have now the pleasure of designing systems, including a lot of these 2110 systems. And John, you introduced yourself, and what was your involvement with developing the SMPTE 2110 standard that I now get to use with these system designs?
Well, so for many years in the television industry, I've been involved in sort of these technology transformations. I had the pleasure of working on the Grand Alliance system, if anybody remembers that. It's still in use 25 years later. And in my role as a director at the Video Services Forum, I was very involved in the TR03 and TR04 document developments, which were really, early work of how to do video over IP. When it came time for that work to move into SMPTE, the VP of engineering of one of the call letter networks asked me politely, said, hey, this isn't going to go anywhere if somebody doesn't kind of take technical ownership of shepherding it through SMPTE. Would you do that? And without really thinking too hard about the implications of saying yes, I said yes. Turns out it was a lot of work. So I've served for the last, I didn't even want to think about how many years this has been now, as the document editor for SMPTE 2110, which in a SMPTE drafting group, the document editor is responsible for integrating people's changes and thoughts and kind of keeping the document intact from an editorial perspective through the process so that at the end it actually represents the view of the committee and gets through all the various ballots. It's a great process. I think it produced a good result, and these specs were published in 2017, which is hard to think back, here we are in 2020, to say in the end of the year of 2017, these were published. So anybody who tells you they're still waiting for 2110 to be finished, they're pulling your leg. It's been finished for quite some time. The work continues in some of the obscure corners, but the core of it is quite thoroughly baked.
So we actually had many designs for 2110 systems in 2017, and we actually had some of them go live in early 2018, and they've been live since 2018. But before we dig into that reality, a little bit more of the science, John, what was the motivation to even go to IP?
Well, in the years I've been doing television since the 90s, some people I've met have been doing television since the 50s. Most of them are retired, thankfully for them. And the one constant through all of television has been this mountain of black coaxial cables. And if you go to the basement of any broadcast center, you lift up a floor tile and you find mountains of black coaxial cables. And we've been doing television on those same wires forever. And so the idea of moving away from that has been kind of earth-shattering. And it's not about the wire, right? Wire's wire. We love wire. We're all kind of, have a funny attachment to it. But the notion is that these router-based cross-point architectures were very limiting in what you could do in a television facility because they were always size limited. You had a 512 square router, or you had a 1024 square router if you were super wealthy. And that was it. And people would have meetings and arguments and, crazy discussions over what can we do to get 3 router ports opened up so I could do a new thing. So as we thought about IP, we thought, well, it's going to scale differently and maybe it'll scale better. When we first started in 2110, the 10 gigabit switches were just becoming affordable. And by affordable, I mean still really expensive. And now, we've watched in the couple years we've been at this, 10 gigabit has now become the everybody table stakes, relatively inexpensive switches. And now the 25 gig and 100 gig ports are the sweet spot of the market, and 400 is shipping and 800 is in discussion. And that's just a huge thing. People talk about, Moore's law and everything doubles every 2 years, but it really does. And it does with reliability. And so in just the couple years that this has been working its way through the standards process and into the early adopters, what used to be super expensive is now the low end, and what used to be exotic is now the middle. And now we're working on things that are truly spooky science for the future. But what this lets you do in a television plant is that everything is connected to the router now. So you can do things you never thought of doing before. And the router usually isn't out of ports in anything like the way it used to be. And if
Right.
it is,
Yeah, the horizontal and the vertical scale is huge. So, but before we talk about those, what you've called super gigantic systems before, talk about, SDI still works, and there's still places where I might want SDI, even in a new system.
hey, I love SDI. Don't get me wrong. We make and sell. I mean, my other hat besides CTO is I'm a product manager and product management director. And so SDI is a fine system. The factory makes it and sells it. And honestly, it's at the peak of its development. The saying goes that the last guy to buy a buggy whip got a really nice buggy whip, and it had a perfect little gold spiral in the handle, and it had a feather design that made it 2% better at getting 2% more mileage out of your horse. And so and there were 3 sales guys fighting over selling that last buggy whip. So it is definitely, SDI is still the thing that drives the industry. We have a lot of it, and it does every feature. It's the most finely tuned machine there is. So if you're building a facility where you just need to get a couple more years, 5, 10 more years out of it, it's never going to do UHD, it's never going to do HDR, it's going to do a very fixed workflow that doesn't require flexibility. SDI is worth considering because you can get a nice simple SDI router frame, get demuxing of the audio on the way in, muxing of the audio on the way out, frame synchronizers on the ins and the outs, multi-viewers built into the whole thing, double density packaging. A little half rack IP3 router does just about everything you could want in a mid-market TV station. It does it at a great price point. So no, SDI is far from done, but SDI is definitely in that life cycle spot where it has the features it has, they work great. But the promise of IP is about the future and about the things you don't know you need yet, or the things no one's told you you have to do yet. And those things include.
So when do I actually need? Right. So when do I actually need IP now then? I mean, you talk about UHD. There's also things like high frame rate cameras where you add a lot of bandwidth very rapidly, but also just that horizontal and vertical scale that you're talking about, the size of the matrix, but maybe the physical distances as well.
Yeah, I think we've done a number of IP projects that could have used SDI, except when you pencil in things like in one of them, there was, 50 new signals are coming from this room over here, and 100 signals are coming from that room that's over in a different building, and 20 signals have to drop off over there. And by the time you added in all of the optical links that had to go between all the different parts of the facility down to where the new system was going to be, we actually kind of worked it out in SDI and said, there's so many optics and so many ACOs, because each of those optic paths, they wanted some redundancy because fiber has its own failure possibilities. And, when we really worked out that, plus the fact that those signals would all be a little bit wild by the time they got downstairs, so we needed synchronizers anyway when they got downstairs, the SDI system actually penciled out better, just on a sheer does the same thing standpoint, not even mentioning that, but you get breakaway audio built in there too, and breakaway VMs, which no SDI router does that. So there are times just architecturally that IP will be the right solution just because of optics and redundancy and the sort of inherent frame synchronizer in many of the gateways. Then you get into things like UHD, where UHD is 8 times the bandwidth of HD. It's 4 times the bandwidth of 3 gig. Just remember that. It's 4 times twice the bandwidth of HD. And so it's a little different in every equation about SDI, right? Because yes, you can route it as 4x3 gig, and if you're doing a little bit of UHD, you can do that, and it works great. But if you're doing a lot of UHD, that just is a lot of stuff to do. So in IP, UHD facilities really go up a lot quicker. And this cable contraction, the fact that a single 100 gig link will carry, let's say, 32 3 gig signals each direction on what's basically 1 cable assembly, or 2 for redundancy.
But 2 fibers, yeah.
Yep. So a number of our SI partners talked about what drives the cost of projects. And when you get right down to it, the number of wires is a driver, not because of the cost of the cable, but because each wire gets made, is labeled, is dressed, is racked, is stacked, is strung, project managed, overheaded, managed, all those things. When you reduce the number of wires in a project by a factor of 10 or 20, it can't help but reduce the cost of the whole project because it reduces days on site and it reduces number of everything.
Just fewer touches in general. So one of the other cool things we can do, in addition to putting all those HD signals on a single strand of fiber, we also roll in the timing now. We don't have a separate infrastructure for sync. We have PTP. So talk a little bit about where PTP came in the 2110 standard and what that gives us.
Well, the 2110 standards benefit from a lot of things that were happening in the industry around us, right? So we kind of took the role of integrating these technologies, but in fact, the SMPTE 2059 effort, which is led by one of my colleagues, Lee Whitcomb, has been going on in parallel for quite some time, just getting timing onto IP. And you might say, well, why would I want timing on IP? But if you think about building a plant without PTP, okay, you've got to run blackburst everywhere. But if you're going to do HD at some funny frame rates, like you got to do some 2398 or something, all of a sudden now, oh, well, you need tri-level for that. But that tri-level is at 2398, so that's different than your 5994 black. Oh, but the audio guy wants DARs. But the other audio guy doesn't like DARs, he wants word clock. And then you get the people over in transmission that really want 10 megahertz, and 1 pulse per second because they're SFNing. And pretty soon you've got like 6 or 7 different analog reference signals that you're plumbing to all over the plant. And that's just a whole nother set of those. Remember we talked about those black cables? Those are the ones at the bottom of the pile, right? So the nice thing of saying, I'm going to take this single 100 gig cable, plug it in, and it picks up all these videos and audios. We haven't even talked about audio yet. All these videos and audios, and the timing for everything. And then that timing is made redundant because, I've been in a lot of plants. I've seen people that have actually built redundant SDI routers. It's rare. I really haven't seen very many plants that built redundant sync trees. And trust me when I say, when a sync DA somewhere up the chain fails, it can take a surprisingly long time to sniff out why things are really, really wonky in your plant. And it's because a sync DA failed, one of the cheapest things in the plant, and yet the one that's very crippling. So the idea that you get this same redundancy architecture that we're applying to the signals applies to the timing too. And now you have redundancy of how PTP is delivered to all these pieces. It's actually overall a pretty big improvement in the systemic availability.
Right, a lot more flexibility in the overall models that you can use. And you guys pulled from IEEE 1588 for that PTP, right? Mm-hmm. You guys similarly used elements of AS67 for the audio. Now we can talk about that audio, John. Where did you guys get that idea?
Well, a big part of TR03 and 2110 is this notion that we would not invent new technologies, that we would leverage things that existed if they existed. And a big part of that, 1588 and the SMPTE 2059 effort clearly, existed, and we didn't need to invent anything. And 2059 really even just says how to use PTP for television. In the same way, the audio industry, through the Audio Engineering Society, the AES, they've been working on audio over IP for years and years, and they've done it from the starting point of every vendor in the audio world had made a unique and different way to do audio over Ethernet. And there were at one point, I think, a dozen different ways to do audio over Ethernet. None of them talked together. They were all their own thing. And so that was a pretty strange, difficult time in the audio industry, and there was a lot of painful down selecting that the marketplace did to get down to a smaller number of those. And the Audio Engineering Society said, look, we got to put a stop to the crazy and have a standard. And so at great pains, they developed AES 67 as the standard. So we come along from our television perspective and we think, let's use that. Let's not reinvent. Let's especially not open the lid on it and re-have all the arguments that they just spent the last so many years having. So that's really why we just said, we're going to use it and we're not going to mess with it. So you might get a copy of SMPTE 211030. I think it's actually available for free on the SMPTE site these days, just as part of the whole, let's learn things while we're all working from home. The 211030 is a disappointingly short document. It doesn't mean it was short to write. It took us a while. It started out bigger and got smaller. But all it says is use AES 67 and use it exactly like this, because AES 67 lets you do a lot of different things. And that's actually where the challenge of audio for television comes. And it's always been the case, right? SDI, you got 16 channels, you use them however you want. And believe me when I say, I've seen people use them every way that was possible. It's just, the number shall be 16. Other than that, you're on your own. In IP, there's a lot of choices you have about how you pack up the audio. And so when there's choices, there's ideas and there's creativity, and that's good, but it means you can pick the best thing for your system. So Cassidy, what we've seen is we've deployed these. I mean, we made these things really flexible. How's that flexibility playing out in the field?
Well, that's definitely been one of the challenges, is that, we can see within the standard and within our devices the flexibility to do 1 channel of audio per multicast stream all the way up to 8 channels per multicast stream and different mixes in between there. But it usually ends up being sort of what is the lowest common denominator of the mix of devices in the system, right? So it'll be maybe 4 channels per stream to deal with a certain device, or you could do the 8. It really is different almost every time, depending on those devices. So to your point, opening up those options allows flexibility, and then it becomes another design exercise, really.
Right, and I think, certainly the commissionings and things that I've seen and been in a lot of phone calls and a lot of commissionings, the video is up and going usually the morning of the first day. You get the video up quick, everyone cheers, and then they start arguing about audio. And then that discussion of audio and how are we going to organize the audio usually takes the next day or two, and then it's sorted. But definitely there's a lot of use cases, right? Because in the playout world, where really you're making finished channels that are going to air, the audio is organized and the playout system comes out with the audio it has, and you keep it together. You keep it in usually like 8 channel streams, and even those tend to switch with the video almost all the time. But in the production world, the audio takes a left and the video takes a right, and they don't meet up again until the end of the truck. So it's a whole different experience there, where the way they use audio is completely different than the playout world, and frankly, completely different from truck design to truck design, depending on what other equipment how it's put together. But
we have another level of options, as well in SMPTE 2110-40, John, and talk a little bit about the thought process there.
Sure. I mean, there's an unknowable number of things that people have mapped into VANTs over the years. And if you tried to write down the list of all of them, and there's a registry that actually has the list of all the registered DIDs and SDIDs, but there's stuff people do that isn't registered in there too, because there's a whole user space, so you could do whatever you want. And so that's good, right? Because people have all kinds of interesting use cases where they want to get data around their plant, and those SDI cables went the right places, so it tags along. What we see now is in 2110, we wanted to do the right thing with that data. And the right thing, just like with audio, varies from facility to facility. So in production itself, there's things like HDR metadata that are going to tag along there. Okay. In playout, there's all manner of stuff that's traditionally put in the VANTs that's super important. Things like subtitles, teletext, captions, triggers like SCUDY 104 triggers that trigger all the downstream ad insertion. Those ads pay for everything, so you better get them right. And so it was super important to get this stuff right. And what we did is we acknowledged that you might have multiple streams of VNs and need to, do a little bit of picking and choosing. So on the audio side, different products have different capabilities. What we've seen is also on the ANTS data side, some products just take everything and throw it in one stream and away you go. Other products have filters and can pick out, certain classes of ANTS data go in this stream, certain classes of ANTS data go in that stream. And then at the receive side, there's picking and choosing too to figure out how do you integrate all those pieces. It's just ANTS data has always been a little bit the Wild West, even in SDI. And I think that that's a piece that is going to have a little bit of settling pain in the IP world. I mean, it works, it gets through the system, it does the job, but we will come up with a lot of creative ways to use what we just built. And
new ways to use it. Yep, that's what I expect as well. So really, I haven't seen a whole lot of issues with the 2110 essences themselves. And every system we've built has been sort of a mix of 2110, maybe tying into compressed IP or SDI. And the cool thing about the standard is you're allowing for a best of breed system even in the 2110 space because people are going to interoperate potentially. But what I've seen is a best of breed regardless of format. So people pick the switcher they want, the production switcher, regardless of whether it's SDI or IP, and then the audio system they want, and then maybe they have a 2110 core that everything ties into somehow. So it's kind of from my side, I don't feel a pressure to go all IP, but what's your thought, John, on the pace of change and how we tie into those other systems?
Well, so I've been doing television my whole career, for brief period before that, mostly. And one axiom I've seen about television engineers is that if they own a piece of equipment and it has even the slightest hint of life left in it, they will keep it, and they will keep it in a rack in a basement in a storage room somewhere, because they know that one day if this fails and that fails and that fails, I still have that other one in the basement. I could drag it out and I could keep the show on the air. And that's a virtue, right? That's a positive attribute of our industry. But at the same time, that means that SDI, because that's what's on all the connectors of all that gear that's sitting in those closets, SDI will be with us for a long, long time. And SDI routing is holding together a lot of facilities today, like every facility except for a few. So you can't just say, oh yeah, forget about that, do this. Every project, except maybe the greenest of greenfield builds, has existing infrastructure. And it's super important from the control perspective to tie together all this stuff and to say, look, there's an SDI matrix and it's connected this way to some IP stuff, and the IP stuff has its own routing domain and so forth. One of the biggest things to think through in building systems is how do these things all fit together from a timing and a sync perspective, but also from a plain old routing system perspective. Because at the end of the day, an operator sits down and punches up VTR3 and expects a signal. They don't want to think through, what's got to happen to make it happen. They just want to punch up, it's funny, it's still called VTR3, even though it hasn't had a tape in it in a long time.
That's right. Yep. No, I mean, and as a former operator, I can say, I don't want to have to think about what protocols the router is speaking to a device or how many sub routers there might be or whether the core is IP or SDI. I want to be able to work on an SDI truck one day and then walk into a system 2 days later, maybe if I'm a freelancer, that's an IP system and not know the difference, still have a destination source take performance that is quick, live production quick. And we're lucky enough with our system that we speak a lot of languages, every language we've ever spoken, right? From our router going all the way back to Leech. But even today, and that ties into something that you're working on with NMOS, right, John? We have protocols with different devices in the IP space. So speaking a lot of languages is important so you can keep that under the hood for your operations staff.
Yeah, I mean, NMOS is the sort of the current wave of innovation that's happening on all these devices. So everyone got super focused on the data plane, 2110, and getting the video and the audio into IP, all that. That's done. Like every product you want to buy probably has an orderable option to do IP at this point. The next step really is making them controllable. And so this AMWA NMOS, ISO 4, ISO 5, they've been stable now for some number of years. I mean, those at about the same time as 2110, really, those documents also stabilized. And they've been climbing in deployments. So if you look at the JT&M tested program and its published results from a year and a half ago, there was some number, I don't know, 10 or 15 products in there that did NMOS. And then the results from a year ago, there was maybe 20 products that did NMOS, right? And then the results from 6 months ago, there's like 30. And the ones that were published just a few days ago, those now are up to like 40 some odd products in the industry. And those are just the ones people actually signed up and were, prepped up to bring to Houston to actually test. I mean, most companies are now implementing this in their line of things. And if it's not in there today, it's in a software release that's scheduled. So what does that mean for us on the control system side? I tell you, it's awesome, because without NMOS, we had to write a driver for every different product. So some system integrator would say, oh, I saved 38 cents by using this box from Yoyodyne instead of the one that you have a driver for. And we'd say, really? Okay. So writing drivers, I mean, customers hate paying for drivers. And honestly, we don't like writing drivers either. Writing drivers is the worst business we're in. So we don't want to write drivers. Customers don't want to pay us to write drivers. NMOS is the solution, because NMOS, at the end of the day, NMOS is a universal driver for IP infrastructure. So if a device speaks NMOS, we can go in the controller and we can pull it up in the registry and say, oh, look, these new things showed up. This one's called Tony's desk. This one's called Fred's editor. This one's called switcher input 37. Hey, who knew the switcher had that many inputs, right? And then you give them names, and there they go in the system and working in a very simple workflow.
Right. And that said, one of the large designs that we've done with a lot of NMOS potentially also includes SWP08. So, so we will continue to see these mixes.
Yeah, there's no escaping the past. As much as the low-level stuff, we're doing a lot of IP now, there's still router protocols that have been around for years and years and years. And SWP08 and NV9000 and Quartz protocol and LeechXY, which really came from Headco, just to go back even further. And so all these legacy protocols, they express the operator intent, right? So when the operator says, I want VTR3 on, monitor 7, okay, that's coming through a routing protocol that understands names and status and tally and all that stuff. That, in NMOS, that translates into GUIDs and IP multicast groups and so forth. But at the top of the system, these legacy protocols tie into automation and tally systems and workflow management systems that have a whole different life cycle. And so these top level protocols, they'll be around a long time, and that's okay. We've got as an industry hundreds and hundreds of staff years of work into systems that manage those top level protocols. We're never going to walk away from those.
So another thing that comes up with these control systems now more and more all the time is the idea of bandwidth management. And we talked a little bit about the huge scale that we can go to on these IP systems. I mean, we can do a totally non-blocking core in a single switch with 10,000 3G signals squared or thousands of UHD signals squared. Why do I need a bandwidth management system, or when do I need bandwidth management?
Well, in the SDI days, if someone tried to sell you a blocking SDI router, an SDI router that there were certain combinations of ins and outs that it just couldn't do, you'd throw them out. Like there was a chair in the lobby for that sales guy, right? And but yet here we are in IP, and suddenly we say, oh, well, systems are blocking. Well, they're not really. I mean, you have to think through and engineer what you're doing. So most mid-sized and large-ish systems, what we see as a design pattern is that you can engineer the bulk of the plant to be non-blocking, meaning you have, one or two big switches, some things are hooked directly to the spine, other things get aggregated through leafs, but you engineer the bandwidth. In other words, you engineer the system. Well, this is television engineering. We engineer everything we do, right? There's a spec on how far from the connector to the label on every cable. So, we're used to engineering things. Now, where you need bandwidth management in most systems is when you start having oddball stuff. You have, a dog leg to that other studio where you've only got, 100 gig, and there's more than 100 gig worth of stuff there, so you got to be careful. So bandwidth management definitely has a place in some system designs, but we do that through a combination of, yes, we count bits, but we also count resources, because operators and systems, frankly, think in terms of resources. So it's not, oh, there's 100 gigabits to there. It's really, there's 32 tie lines to there, and we're going to allocate those like tie lines, because that's the operational methodology. Is I can do 32 things over there. It's not about bits. It's about, what can I do? How can I use it? Can I bring in 12 cameras and this and that and that? The answer is yes. So management is a combination of keeping track of resources and keeping track of bandwidth at a low level. But ultimately, people always ask me, what does the system do when a port oversubscribes? And the answer is ports don't oversubscribe, because we get in front of that and we vet the request and make sure that you don't, the system, if you ask for something that can't be done, we don't do it. And we respond just like a routing system will, and say, no, that route doesn't status because, look at your threads display, and you say, oh, well, there's no more tie lines or whatever.
Yeah, you and I, John, have done over 10 of these 2110 systems that are now deployed in the field just together, you and I. Globally, I know that we've done more than that you've been involved with more than that, and I have not seen a bandwidth management system really come into play in these systems yet, just because they're so scalable in a non-blocking fashion. So it's been very nice. We're not talking about a tie line between two routers in the same facility anymore. We're talking about a tie line across two separate facilities, maybe. One of the other big questions people ask us, go ahead, John.
I was going to say, one of the things that comes up a lot more today than it used to is actually the long haul case. How do I federate between my, my New York studio and my Los Angeles studio? How do I expose, a half dozen signals from my router to them and vice versa, and give the remote studio a little bit of control, but not complete control? And that it's that thing of, we're going to work together, but we're going to be separate, and we're going to federate, but we're going to be independent. And so that's a lot of the new things also is it's IP allows things to be connected that didn't used to be connected. And so now we get into the management questions of how do we control that, and who's responsible and who does what. And it's a new world, but it's a very promising world from an operational standpoint.
Yeah, I mean, we have distributed systems where the edges of the router, what might even be considered the physical inputs to the router, are 10 kilometers from the core, so to speak. And so, you now are pushing out to more devices, more potential interactions with legacy devices or other non-standard devices maybe, and it just gives you new things to think about, new mental exercises to go through when you design one of these large systems. And maybe those distant systems want the ability to even take over a federated system at some point, depending on the situation. So it's we get asked different questions now with these mega systems. So another question that we get asked, and I know we have a video for this as well, is how do I know what's on the wire when I have a 400 gig or a 100 gig link and I have different signals dynamically changing through there? How do I know what my router looks like? And
well, so this is a big part of the new normal, right? Is we have, historically in SDI, it was so painful to wire everything that you made a bunch of as-built drawings and you taped them up in a folder on the wall. And if you ever had to know, you could go look. But now we have a little bit different challenge. Now we have this question of how do I get that virtual wiring diagram? So thankfully, you put together this lovely video of how we do that.
Yep. So what we see here is our SDNO path view, and this is literally dragging over, I want to see everything that Studio A is routed to, and I can get a dynamic detail drawing in HTML5 of everywhere it's routed. And if I change my route, you'll see it update live, and I can zip around and I can move the nodes on this to lay it out in a way that makes operational sense to me. I could see a workflow related to an operational position or a troubleshooting workflow for an engineer. And again, it's fully recognizing that I can't do a detail drawing and call out a single wire and say this is always the same thing for these large systems.
Right. And I think the important thing to get with these live blueprints here is that this is data from the real system. This isn't some, creation of what we meant to build. Everything here in terms of, right now it's showing all the drilling into the detailed stream and details and things like that. This is all out of the live running system. So it's as fresh as could be, and it has different details for different users. So the operational user might not care about all these stream details, but they care a lot about the audio breakaway detail that's also in here. Whereas the engineering user might want to see something different. These views also are nice because you can build your view and save it when your workspace with your name, and when you sit down tomorrow to do that same show again, you pull it up. So that's a whole nice thing we get.
Yep. So John, we have time for me to give you a bonus question, so I'm going to do it. So a little bit off of IP. Of course, we moved this over IP, but there's a lot of talk now about HDR, of course, and we support and can convert a whole bunch of different HDR colorimetries to different HDR colorimetries. But there's a conversation now about LUT versus anything else. So talk a little bit about your ideas on how we handle HDR.
Well, it's a great time to be in the conversion business because there's, HLG, PQ, S-Log, standard dynamic range, the one we've lived with all these years. And then in UHD, there's also 4 different ways to put the bits on a wire. So, there's every combination of these things happening in the wild right now. And even within a facility that's all engineered to go together, you'll find equipment that does each of those things. There's 2 different kinds of workflows I see with HDR, and they're a little different. One is very much the shooting, shading, truck kind of workflow where every piece of the conversions of the cameras getting turned into the show or archive footage that's SDR getting turned into HDR to go into the switcher wants to be adjusted by a human who's looking at it and is picking that I want to add a couple dB of white gain, I want to play with the slope on this one thing's a little hot, I'm going to shade it out a little bit. And so you get this kind of camera shader want on things that aren't cameras, right? And so that's a big part of HDR conversion, is dealing with all the stuff that's not in HDR or not tuned to your show's look and turning it into that. And so we provide like live operator sort of controllability for all that. At the same time, on the other end of the spectrum, in the sort of play out world, and even in some very engineered productions up in the sort of second tier of them, there's LUTs that are engineered to have a certain visual look and have some funky cross color stuff and a little bit of punching in the low end, and things that are not something an operator on the fly would exactly ask for, but are engineered looks that people have spent a lot of money and consultants and all kinds of people who make LUTs, so there's a whole cottage industry there, have created these LUTs. And so there's both things are wanted depending on which end of the spectrum of production you're in.
I've heard you say that shaders are becoming more like film colorists when you give them these HDR handles to play with sometimes, and I've definitely seen that.
If you try to sit down at that set of controls and make the camera look better than it looks right now, you'll quickly discover that you can only make it look worse. And those guys who do that for a living, they look at it a whole different way. Those are very special people. And HDR makes their job about 10 times harder. So it gives them more controls and more knobs and more beauty when they're all done. But it's definitely the part of the production that is new for everybody. And it can look so beautiful on the truck, but you can so easily make a show that doesn't translate back into SDR if you're not careful. So
But
I'll tell you, production is a whole interesting, subculture there. And I think one of the things we wanted to close with, if we're up to that, is the Some of our colleagues in Europe actually had put together a truck for an end customer Vidi, but the truck was built by Chromaline. And it's just a beautiful physical truck, but also did use a couple of our processors and things, and we're very pleased that they've allowed us to make this nice piece about it. So any parting thoughts, Cassidy? Or?
No, just that we've been doing these 2110 systems since the standard was ratified, and we have UHD and HDR systems that have been live for over 2 years. So I look forward to doing more of those with you, John. And of course, we have our Magellan SDNO that speaks all these different protocols that we talked about, and will continue to enable you to have a best of breed system with different devices across SDI and 2110 and 2022-6. And we also have the Selenium Network Processor, which can process the video formats and translate between them and allows us to connect these systems. So thank you for that, John.
No problem.
And thank you, everyone, for listening.
Thanks a lot.